Okay, so we're going to talk today about direct variation. And direct variation is kind of a topic that we deal with when we start talking about slope and we start talking about rate of change. And so you see on this first slide here, direct variation is really, it's just kind of the relationship between the y value and the x value in a graph. And we have a specific, you'll notice that we have a specific symbol where we talk about the y over x equals m. Now, everyone always asks, why do we use m? I'm going to be very honest. I don't know. I've never met anybody that did know. But m is the variable that we use for slope. Okay? So, a couple of things to think about. Direct variation, their equations always in the form of y equals mx. All right? The m value, which is the constant rate of change, is the change in the y. That's the up. So it's the up versus the over, the change in y over the change in x. And if it's direct variation, it is always going to start at the origin, and it is always going to be a straight line. Now, the steepness of the line could change. Okay, so we notice that it starts at the origin. So we have an example here for trail mix, and we're comparing the cost to the weight. When we compare the cost, we're looking at the y values. So because this started at 0, we could say that it went up $7 for every 2 pounds. So when we look at the equation, our slope would be 7 over 2. Now, could we simplify that really as a fraction? No, 7 over 2 is perfectly fine. We could find the unit rate where we divide 7 by 2, and we would get 3.5, and that would be acceptable as well. So here's an example. We're talking about Tyler, and he charges his customers $10 per week plus $5 every time he walks their dogs. And we want to determine, is this a form of constant variation? So I made a table, and I compared the number of walks. So right away, 0 walks, they're still paying $10. 1 walk, $15 because of the $10 per week plus $5 for a walk. $2 is 20, or 2 walks is 20, 3 is 25, and 4 is 30. So I compared the rates. And you'll notice that I said my ratio, or the slope, is going to be the pay, which would have been the y value, over the number of walks, which would have been my x value. So the first one, $10, 0 walks. Then we have $15 for 1 walk, which is $15 per walk. $20 for 2 walks, which is $10 per walk. $25 for 3 walks, which is $8.33 per walk, and $30 for 4 walks, which is $7.50 per walk. You'll notice that these rates are changing every time. Therefore, it is not a constant variation. Okay? So we want to make sure that we understand that it's not necessarily that they go up by $5. Yes, that is, it's increasing, but it's not a constant variation. So, example number 2, we have an equation, P equals 6s. They want to know, is there a constant variation? The answer is yes, of course there is. The reason, because we know right away, this is y equals mx. This 6 is standing for the slope. So, format of y equals mx, 6 represents the m value. We know that that is going to be a direct variation. So here's example 3. Okay, a little bit more practical, and I gave you all of the answers here so you can see those as we talk about it. But we're talking about burning CDs. And the time it takes to burn CDs is compared to the amount of information. It is a direct variation. So they told us that it's going to increase, okay, by certain rates. So we have these different ordered pairs. And what I did is on the left-hand side here, you'll notice I used the slope formula that we have. y2 minus y1 over x2 minus x1. And I picked 2 points. And I picked easy points. I didn't want to use decimals. All right. So my second point was 25 and 100. So I have 100 minus 40. These are the y values. 100 minus 40 over 25 minus 10, the x values, which is 60 over 15, which is 4 over 1. So the slope is 4. So right now I can write the equation of y equals 4x. 4 stands for the slope. Now they wanted to know, the ultimate question was, how long is it going to take for a 700 megabyte CD? So the megabytes are on the x-axis, so I plugged it in for x. So we have y equals 4 times 700, or 2,800 seconds. Now, through our graphs and our equations and tables, we can actually compare rates. And this allows us to compare, are things faster or do they occur at a better rate? If you're going banking, are you going to get a better interest rate with one bank as opposed to another? So you want to make sure that we understand that rates are real. So here's an example where we're talking about heart rates. And we have the heart rate of a rabbit. And they give us the equation y equals 3x. And then they give us a graph that shows us the cat's heart rate. So in the equation, I know that the 3 represents the rate. So it's 3 over 1, or 3 beats per second. Now the cat is a little bit different because I have to look at the graph. And what I did is I actually found the slope. So I took 2 points, all right? So I took point 1, 2 and point 2, 4, and I found the slope. So I subtracted 4 minus 2, it's in my numerator, and 2 minus 1, denominator, and I got 2 over 1. That means 2 beats per second. So we're able to compare the rates, and you'll notice that the cat, which is 3 beats per second, and the rabbit, which is 3 beats per second, and the cat, which is 2 beats per second, all right, we can compare those, and the rabbit has a faster heart rate. Now, the neat thing with direct variation, if you notice, because it starts at the origin, what I can do is if I want to find that unit rate, I have a value of 1, I can just go up and over to the 1. So I went up 2 over 1, so therefore that rate would have been 2 over 1. Just a little trick there for you guys, and hopefully it helps you out. Alrighty, so that's my quick example of direct variation, and hopefully this helps you get some understanding, and we'll have an assignment coming shortly.